So, hi, I'm Shravya Sharla. I would like to present my project Serverless IoT application along with my team members Rahul and Pooja. So, coming to introduction. Coming to introduction, basically, what is serverless means? Serverless is a computing device which is a cloud computing model, whereas developer write and deploy their code without worrying or managing about the service they are using or the infrastructure. So it states that server management task automatically scales resources and charges users only for the resources which they have consumed during their code execution or their code deployment. So this is basically mean by serverless computing. And we would also like to know about what is IoT involved in it. IoT is nothing but Internet of Things, which stands out for the transformative force, promising to revolutionize how to interact with the surroundings. Potential efficiency requires an architecture that is scalable and very cost effective. Coming to serverless computing, it has three platforms: infrastructure as service, platform as service, and server as service models. So within the serverless architecture, developers can build their highly scalable and efficient, effective and efficient applications with IoT that unlocks the new possibilities and drive the innovation across the industries. So which has revolutionized IoT applications. These offer scalability, effectiveness, and efficiency. Development of this IoT applications with serverless, which utilizes infrastructure as service, platform as service, and server as models. So, coming to background, Rahul will continue over it.
Yeah, hi. So, hi guys, this is Rahul, and I'll be explaining about like why we are choosing a serverless as a service over a platform as a service or the infrastructure as a service. It's simple because it has a greater ease of use. Instead of like we maintaining the infrastructure and management of everything, like it is just it is just an automatic management system, and just we need to go through the updates and the security patches. Like all the maintenance updates and security patches are generally managed by the providers, and uh, they provide like several benefits, like specific scenarios where it might be preferred over platform as a service and infrastructure as a service. Like the solutions are ready to use and require like a minimum setup and the configurations, and it is just a pay as you go. So the resources that what we use or whatever like we needed, just we use based on like what we are required, and uh, it is cost efficient and operate on a subscription based pricing model, and SaaS applications can be developed very quickly. Coming to the problem statement, uh, simple, SaaS provides ease of use and abstraction of infrastructure complexities. It enables the users to focus on utilizing the software without managing it and underlying the platform. It's a basic cloud computing model where developers write and deploy code without worrying about the managing, and it abstracts away server management tasks, automatically scales resources and charges users only consume the resources during the code execution, and automatic. It is just automatic management, so just no need to worry about everything. Like providers will be taking care of everything. Like and it is like optimizing cost efficiency by charging users based on the actual usage rather than fixed infrastructural usages. Okay, coming to integration and the code path, and my friend Savia will be explaining it. Okay, thank you.
Coming to integration with services, with AWS services, we use many services like AWS Lambda, S3, Amazon S3, Amazon SNS and API gateway for communication between the two services, and Amazon EC2 instances for serverless computing. So the key component for building this IoT application is AWS Lambda, where it enables developers to run the code in response to their events without provisioning or managing servers. So Amazon API Gateway, it allows developers to create, publish, maintain, and monitor secure APIs at any scale. So API Gateway can also be used to expose RESTful APIs that enable communication between two IoT devices with backend services and front end. So DynamoDB is like a fully managed new NoSQL database service that provides fast and predictable performance, and it also can be used to store and retrieve data which is generated through IoT devices, and it is suitable for most of the IoT applications with large volume of data. And uh, these provide object storage with Amazon S3 is like object storage with high durability and availability and scalability. It can be used to store static assets, images, videos, configuration files, etc. So coming to the code part, and I would like to share my screen. I hope the screen is visible now. So this is the code structure, which contains Node.js applications and JavaScript files. So here the serverless command will guide you to the project. If we have the AWS credentials, it will go into the account. And first we have to do the SLS deploy, which is serverless command used to deploy the project at any time of running. So we deployed the AWS Lambda functions with the essential information with an API endpoint, and it will be used to display the command output. So these are the commands for deploying the application in the cloud with serverless deployment, SLS deploy function, hyphen my API. My API will be imposed into that, and we will invoke through the messages hello and hyphen log images. So first we would deploy the YAML file. We would add all the configurations like to know the code where it goes next to it. Then we can these are the YAML files. We can see when we are deploying it, but I would like to show through the package .json files. So the keywords are we are giving the keywords as Lambda, AWS, Amazon, Azure. Any other serverless platform can also invoke this. Like we can use the AWS or Google platform or uh, Azure, anything. So all the versions are maintained in this YAML file. Serverless.yaml file will be having this. And coming to the code part, mm, we use login.js for logging into the dashboard, which imports the module and exports the content. So for logout, we use these commands. It just says that if you are already logged out or logged in, or it says what's the current state of the process. And for all other plugin installations, We use this plugin.js file to import all the plugin managements which are required by the project. And for uninstall also, we use that uninstall plugins. So in the lib folder, we can see the classes and the CLI commands and configurations and plugins to utilize these schemas. And within the serverless.js, the application goes into the major installation and it installs all the serverless applications. As you can see, npm install -g serverless. So this can run any version through locally installed serverless platform, and it can run locally through install version via npx serverless commands. And this will also check whether the given string, what the keyword it is checking, it's valid or not, or through these functions. And it objectifies and throws an error if any serverless is mm, not mismatched. So yeah, the configuration schemas, like in this model, we use for validations like for error warnings and disability configurations. And the configurations, it has a type of framework version, patterns, and function names. So in the classes, we can see servers.js, like it installs all the lib plugins, which prints the values from Amazon Lambda Cloud. So I would like to show the get started document so you can see how the code flow is going. First, installation of a service model via npm is required. And then for creating a service, you'll create a new serverless project with with the keyword serverless, and you will go into the serverless directory, and then you will give the commands to guide you to the project. For the project, we use, as I told earlier, we use the command serverless template. And then deployment and deploying into the cloud and invoking with the commands again. And we deploy the project into locally. And finally, we'll remove the service. We'll able to see the serverless application running through AWS cloud with the net. So this is about the code infrastructure. As you can see in this methodology, we use front-end commands as amplifier, and user authentication would be the communication platforms like Lambda and Cognito. So API gateway will be communicating with the services with Lambda data and Amazon S3 buckets, and with the domain and certifications also like Route 53, sorry, and certificate manager. And these all will be verifying through IAM process. And the state missions, which has step functions, which calculate the Lambda functions as SAS APIs with the request and the response through it. And asynchronous inter-service communication is done by the event bridge with the front end and back end push commands. So the asynchronous task will be continued with the SNS and SQS with the Lambda output, which has been given through the session manager. So, and the security would be identity access management, as you all know, and the system manager. And for monitoring all the device applications, we use CloudWatch. Yeah, this is the brief architecture of the methodology. And my friend Pooja will continue the next.
Hi. When it comes to experiments, serverless computing can be it is designed with the performance, scalability testing, cost optimization, and all those things. Whereas performance testing, it measures the execution time of Lambda functions for different IoT data processing tasks, where it evaluates the impact of various factors such as payload size and memory allocation to perform it. And it compares the performance of serverless architecture with traditional server based approaches for IoT applications. When it comes to scalability testing, it increases the IoT devices and observes the scalability of serverless architecture, where it accesses the response time and application it want to work on work scale ups and downs. When it comes to cost optimization, it analyzes the cost of running for the serverless IoT application under different patterns, where it optimizes resource allocation, memory settings, and all those things. And where it comes to fault tolerance and reliability, it introduces failures such as network disruption or resource unavailability and functions. This all be done in fault tolerance and reliability. When it comes to integration testing, the test of integration of IoT devices such as AWS service such as Lambda, API Gateway, and DynamoDB and S3, where it verifies end-to-end functions, data flow, and communication between IoT devices and backend services. Whereas scalability and compliance access the security procedure of the serverless IoT applications. Where we come to discussion, we have many things like rapid development, scalability, reliability, and all those things. In rapid development, serverless architecture abstracts away infrastructure management, allowing developers various factors are no on writing application codes. The pre-built services and event-driven architectures developed can equally prototype, integrate, and deploy new functions. In scalability, serverless computing inherits scales which demand effortless handling spikes in working associated with IoT devices. Reliability by rendering management services provided by cloud providing like AWS serverless IoT applications benefits from high availability and fault tolerance out of the box. The reliability terms of focuses like cost-effective innovation, serverless components follows pay-as-you-go pricing model, where users are built only for the resource consumed. Focus on core compliance. Serverless architecture abstracts away from the complications of infrastructure management. Teams can allocate more time and resources to solve business problems and designing user experiences. Where I conclude, SaaS plays a vital role in unlocking the potential of serverless computing IoT applications, and AWS services demonstrate the power and flexibility of serverless architecture. Thank you.